Okay, guys, today we're going to be talking a little bit about imaginary and complex numbers. So the first thing I want to talk about is lots of times people hear imaginary numbers and they think, why in the world am I learning about things that don't exist? Okay, so let's talk about a little bit of the history of what an imaginary number is. So if you guys remember, there's these things that we call real numbers. Okay, real numbers are just numbers that live on the number line that we usually think about. Okay. Back in the 1600s, there was this really important guy named Rene Descartes, and he did a lot of awesome things, but he also did one thing that I do not like. The thing that he did that I don't like is that he named these numbers we're going to talk about today imaginary numbers. Okay? When he named them imaginary numbers, it makes them seem like they don't exist. They actually do exist, and they're super important. The reason that we call them imaginary numbers is because they don't actually live on the real number line. Okay? But they're still very important to lots of things that we do today. So I know it's used a lot in radio and electrical engineering and electrical circuits. Imaginary numbers also help us get into a 3D perspective. So with our real number line, we're sometimes stuck in a 2D realm. So imaginary numbers can help push us into a 3D perspective. So we are going to get a brief glance at imaginary and complex numbers today, and then we are going to see even more how they're used in future units as well. So the first thing we need to talk about is the number I. So I is what's called the imaginary number, and it's equal to the square root of -1. Okay? So basically with whenever you see I, it's never a variable or anything. It always means the square root of -1. And up until this point, whenever we've seen the square root of a negative, we've always said we can't do that. And it's true, we cannot take square roots of negative numbers if we're in the real numbers. But if we push ourselves out and start thinking about more of imaginary numbers, we actually can take square roots of negative numbers. So let's take a look at what that would be. So if I want to express some of these examples here in terms of I, what I would do is anytime there's a negative inside the radical, I can change it to a positive, so change it to positive 64, and then I've just got an I out front. Okay, so basically by having this I out front, it's the same thing as having a negative on the inside of my radical. And then I can simplify my radical just like I would in any other time. So I know that 64, the square root of 64 is 8. So I'd write this as 8I. Okay, and that would be equivalent to the square root of a -64. Okay, we can do the same thing with 12. We would just turn it into I times the square root of 12. Now here, to break down the square root of 12, it's not a perfect square, so I'd have to actually break it down using my factor tree. So 4 and 3, and then 4 breaks down to 2 and 2. I have a pair of 2's. So my pair of 2's get to come out front of my radical, and they get to be with the I. So since I already had an I out front, it gets to be with the 2, and then I have the square root of 3. So that would be the simplified version. Okay. Let's real quick look at C. With C, it's tempting to be like, oh, hey, I have 2 negatives. Those are going to combine to be a positive. That is not the case, so you have to be very careful. 2 negatives with ones on the inside of the radical and ones on the outside, they are not going to cancel out. What you're going to want to do is you're going to want to first convert your radical to a positive radical by putting an I out front. And then I can simplify the radical. So the square root of 49 is 7. So I'm left with a -7I. Okay, so this time I did end up with a negative number out front. And that's totally okay. Okay, I'm going to let you guys work on D by yourselves. So let's talk about some vocabulary. So an imaginary number is really just I. I is the imaginary number. Sometimes we call multiple of i's imaginary numbers as well. So we might say like 8i is imaginary, or 3i is imaginary, or -7i. Okay, anything that contains an I like that, that's going to be an imaginary number. Now a complex number is what happens when we take an imaginary number like 8i and we add a real number to it. So let's say we did like 2 plus 8i. Okay, that would be a complex number. And a complex number always has like a real part, and then we're adding or we're subtracting an imaginary part. Okay, so here's some other examples of them. I could have like 3 minus 2i. I could have 1 plus I, that would be also a complex number. The general form is that we always put our real part and then we add or subtract our imaginary part. So A and B can be any number in this scenario, and then your I is just the imaginary number. Okay, so now we kind of have an idea of what complex numbers and imaginary numbers are. Let's talk about how we add and subtract them. With adding and subtracting complex numbers, basically the idea is just that we can add we can add the real parts together. Well, I'm going to make it add or subtract because this works for both. So we can add or subtract the real parts. And then we can also add or subtract the imaginary parts. So this process is going to look very similar to combining like terms, okay? So if I look down at this example in A, we have 2 plus 5i plus 1 minus 3i. First, I'm going to add the real parts. So I have 2 and 1. Those are the parts that don't have I in them. I'm going to add those together to get 3. Then I'm going to combine my imaginary parts to get 5 minus 3i, which would just be plus 2i. Okay, so this looks very similar to just combining like terms. I can add the things with i's in them together, and then just the plain numbers together as well. Let's do an example. Let's jump to D and do this example. I'll let you guys work through B and C by yourselves. With D, one thing you have to be careful of is that we're subtracting here on the outside, so you have to make sure that you distribute the subtraction sign in. One way to do that is to change this to an addition sign and then make it -1 plus I. So basically I've just taken that subtraction sign, instead of it being on the outside, now it's inside of my parentheses. Then I'm going to combine like terms. So I have a 5i and an I that I can put together. Then I kind of have this loner 1. So the -1 I'm going to put first. So it's going to be -1 plus 6i total. Okay, and that would be the final answer for that one. Okay. Multiplying complex numbers is going to be pretty similar. It's not going to look super foreign to you guys. Multiplying complex numbers is fairly straightforward, but the first thing that you have to do is you have to convert to I. So convert negative square roots to I. Okay. Then what you're going to do is you're going to multiply the radicals together, just like we learned in the last unit. And then you're just going to simplify. Okay, and there's an important note right here that says that I squared is -1. We're going to come back to that in 1 second. We're going to kind of see where we get an I squared, and then we'll talk about how to deal with it. So let's look at example A. The first thing I need to do is I need to convert my square roots to I. So the square root of -9 would be the same thing as I square roots of 9 times I square roots of 4. Then I'm going to multiply my radicals together. So I'm going to get, remember I multiply the outside numbers together, so I get I squared, and then I multiply the inside numbers together, so 9 times 4 is 36. Then I'm just going to simplify. I know that the square root of 36 is 6, so I'm going to leave it like that. And because of up here, I know that I squared is equal to -1. So I'm going to replace the I squared with -1. So that's just going to be equal to -6. Okay, so let's talk about why I squared is equal to -1. So if you think about I squared is just the square root of -1. So if I take the square root of -1 and I square it, remember that the square and the square root undo each other, so they're going to cancel each other out, which just leaves me with the radicand, or the number inside, which is just going to be 1. So that's how I know that I squared is equal to -1. Okay. So I'm going to skip B, let you guys do them by yourselves, and I am going to do C for us, because I'm going to do it in slightly a different order. I'm going to start by converting my negative square roots to I. So I'm going to have a negative I square root of 8 times I square root of 27. Then what I'm going to do is I'm going to simplify the radicals before I multiply them. And the reason I'm going to do that is because I don't want to multiply 8 times 27. Okay? So I'm going to break apart the 8 to a 4 and a 2, and a 2 and a 2. So I have a pair of 2's that can come out front. So I'm going to have -2I square root of 2. And then I'm going to simplify this 27, so break it down to 3 and 9, 3 and 3, a pair of 3s. So my 3 that is in a pair gets to come out front with my I, and I'm left with the 3 left over. So now I'm going to multiply my radicals together. And I'm going to multiply the outside numbers together, so I'm going to get negative 6i squared, and I'll multiply the inside numbers together. So 2 times 3 is 6. Okay, and my last step to simplifying is that I know that I squared is negative 1, so I can replace that I squared with a negative 1. Then I'll have negative 6 times negative 1, square roots of 6. Negative 6 times negative 1 is just going to be 6, so I have 6 square roots of 6. Okay, so this kind of is a lengthy process, but it's all stuff that you should already know how to do. The biggest change is that now I've got that I in there. Okay, let's take a look at, ooh, sorry, didn't mean to zoom that in. Let's take a look at what it looks like to multiply complex numbers if they're already written in I form with the imaginary numbers. Okay, this was actually going to look fairly similar to what we just barely did. We're just not going to have radicals. So our first step that we're going to do is we're going to distribute the numbers, and then we're going to multiply, and we're going to simplify. So distribute, multiply, simplify. That's often going to be it's a common series of steps. One thing to remember that's important in simplifying is that we're going to be converting all of our I squares to negative 1. Okay, so that's like a key component of simplifying these ones. So let's go ahead and take a look at what that would be. So with A, I actually don't have very much to distribute. I just have two numbers that are being multiplied together. So I multiply the two real numbers together to get negative 14. Multiply the two i's together to get I squared. That I squared I can change into a negative 1. When I multiply those together, I just get a positive 14. And I'm done. Okay. Let's jump over to C. So with C, I have 3i that's being multiplied to 2 minus I. This is a case where I am going to have to distribute. So I take the 3i and I multiply it to everything on the inside. So 3i times 2 is going to be 6i. 3i times a negative I is going to be minus 3i squared. One thing I can simplify right here is that I can change this I squared to a negative 1. So then I'm going to get 6i plus 3. When I multiply the negative 3 and the negative 1 together, I get a positive 3. I'm going to do one more thing. I am going to rewrite this as 3 plus 6i. I didn't really change anything except for the order here. It's just that we always like to put the real part, so the part without the i's first, and then do the part with the i's. Okay, let's jump through one more example. I want to do E because it looks a little different than the other ones. So E, I have 2 minus I squared, and it's really tempting to just distribute this squared in, but you cannot do that, okay? What we have to do when we see something like this is we have to rewrite it as 2 minus I times 2 minus I, okay? And then we have to distribute, and the distributing is going to look similar to what we just barely did in C, but now I have more to distribute. So I'm going to first distribute this 2 to the 2 and to the negative I. So I'm going to get 2 times 2, which is 4, 2 times negative I, which is negative 2i. Then I have to distribute this I, this negative I, to everything over here as well. So I'm going to get negative I times 2, which is negative 2i. Negative I times negative I is going to be a positive I squared. Okay. Then I'm just going to do some nice simplifying. So I'm going to combine these two negative 2i's to get 4 minus 4i. This I squared I can switch out for a negative 1. Then the last thing I can do is I can combine the 4 and the negative 1 to get 3. So my final answer is going to be 3 minus 4i. Okay, sorry, I know that last example went kind of fast. But hopefully this helps. You have some more to practice, and then you can also jump to your homework and practice that as well.